Hi everyone, I'm Adrian and I'll show today how to do a morphing with thinking particles. So I'll show you how to make two object morph from one to another using volume breaker and to look more or less seamless. So let's start by creating an object. So we'll do torus node because it's more complex looking, and let's say sphere. Okay, so let's create our thinking particle object. Okay, so first we want to break the main object into chunks. To do this, we'll create a group and we call it A chunks. This will be object A, chunks from object A. So let's see. Let's create a new dynamic set. Create an operator, generator, object to particle. And let's pick our torus node. Okay, so we also want to create a group for our main objects. So let's see. Set this to A full. Object to particles, instance shape. So we want to instance the shape of particle and also want to track the position of the object. I also want to hide the origin. Now to show it in viewport, you need to enable in master dynamics. We need to enable show mesh, like so. Okay, so now let's see what we have. So this is from thinking particles. Next, we want to break them based on some activator like a box or something else. So let's call this create base object. So let's animate an activator. So let's use a dummy, a point, like so. Let's animate it from 0 to frame 10, like so. Okay. Now we need to create a dynamic set that will update each frame and check if it can break the object based on distance from our point. So create a new dynamic set. Okay. So let's add a group. We need to use A full because we don't have chunks yet, and we'll use operator, volume breaker, volume break. Connect particle to particle. We want to move new chunks into A chunks. So we want to use helper, and we'll use point for the activator. We'll play with this threshold value soon, and let's try it right now. We might want to decrease this value, raster value. Okay, let's see. To see more, to see the results more clearly, we'll create a velocity operator. So, and we'll set it to go in random direction and have some big speed with a big variation. Let's see if it makes so. So you see that it's not activating yet. So let's try to decrease the chunk raster. Okay, density is 1000. Okay, so let's set it to 5. Don't make it too small because it might crash here. Okay, now it's working, but the chunks are not moving. You see the artifacts here. So we may also add edge paste. Okay, it doesn't work with fixing particles, but to make it work, to make the chunks activated, we need to increase the threshold value. The threshold is radius from the point to our chunks. So let's set it to 100. Okay, now works. Okay, so as cool as those chunks looks, sadly we will not use those chunks because we want to create the impression that they actually morph into this object. So to trick the viewer, we will use chunks from the second object to emit from the first one. So let's see. We'll need to create at first frame chunks from object B. So to do this, we'll go to create base object. We can create another dynamic set if you want. So now we'll use the same. It's not a big difference, but we'll keep it together. So let's go operator, generator, object to particle. So pick sphere. This will be object B. So let's create a default. We actually don't need this group. We can use all group because it's temporary. But just to be clear, we'll use a special group. So object to particles, instant shape, and hide. Now we want it to break it as soon as it is created. So let's add an operator, volume breaker, volume break. Okay, so we'll activate it 100%. We want B chunks to create. We set activate 100%, and we also decrease raster size. Now it's better for this tutorial to have the same amount of chunks. So what you can do is to disable one, for example, these two operators, and look here at the top. You have 137 chunks. Now you disable this one, enable this one. So we have more in the sphere, so we can increase this value. So we'll have something around the same value. So something around here. The closer you are, the better it will look. Okay, we'll let it like this. Now let's see. Okay, what's important? We need to have if we'll have a different amount of particles, object A needs to have more particles because it will those particles will hide, but having less particles in object B will make it so it will not recreate the full object, and it will let some holes. So let's make sure we have less than a particle. So okay, let's set it like so. Okay, so enable this. Let's rename it to create object A, create object B. Okay, we'll move the chunks into B chunks. So now we should have a chunky sphere and a chunky torus node. Also, I would like to adjust a little bit the animation of the point to start a little bit back, to not activate it. Okay, or maybe scale the animation a little bit more. Okay. Now, what we want to assign for each particle which is emitted from the torus node a chunk from the sphere. But before this, we want to save the original sphere particles. So let's do this. To save them, we can save them into a memory variable, or you can just create a new particles and reference to those new particles, which I'll use this method because later it will be easier to attach those particles to object animation and so on. So let's add a new operator, generator, position born, and we'll born from this particle. We want to pistol shot one particle, and we want to create a new group. We call this group guides. Also, we want to make sure they have a big lifespan. Don't forget about this because we have problems. Also, we don't want any speed, any variation in direction. Okay, so now it looks okay. Let's rename this to create guides. Okay, now let's see, break A. We want to assign. No, we want to set a reference first. Go to operators, reference, set reference. So we want to set reference from chunk particles to our guides particles. So then, having the reference, we can now mess with the position and alignment of the chunks, sphere chunks. So to do this, we'll do it like this. We'll create a new group. So we'll call this assigned. Assigned. So what this will mean that we'll iterate for each A and B chunks, and when we'll find some, we'll find for each A a pair from the B group, and we'll assign this particle to take the place of A chunk. So when this A chunk is generated, when you get fragmentation, it will take a particle from the B chunk and it will move it in place of the A chunk, and it will delete that chunk. So we don't need it. We want to use, instead of the A chunks, we want to use the B chunks. Hope this makes sense. So let's for this we'll need PPS AB. So go through operator, iterator, and add a PPS AB. So we want sorry, we want to iterate over A chunks to B chunks all. So when we find them, well, what we want to do is to we want to kill the particle A. Particle die. We want to set the B position to A position and alignment. So let's expose A position and A alignment, like so. Now we'll use particle data. Sorry, not this one. This one from this tab, from operators, because we want to get the we want to set the value, not to get. So we'll use position and align, like so. Now to not mess with to not iterate over the same particle again, we'll move the processed particles into another group. So create another group. This will be for our trash particles from A. So let's create a group, one for A, and another group. This will be for A assigned, and it will go, particle B will go on tree, because now it will be an A particle with a different shape. So also don't forget we want the velocity. Okay. Let's see what we have now. You see now it breaks and takes the actual particles from here. So we still have some original particles, but we'll mess with them later. We'll scale them down to 0. So let's set some colors. So we want for A chunks set a blue color, like so. For A assigned we want some red color. Okay. And for guides, let's set it to green. Okay, so we have there our guides. Now what we want to do next is to create another dynamic set. So let's call this assign maybe. Now on this dynamic set we want to check at time interval. So we want them to fly around, for example, to maybe be affected by some noise. We also may want to try some spin. Let's see, dynamics spin. So 3, 5. So let's see. So we'll have something like We also need to, let's see, spin. We also need to set the spin to the B particle. Okay, we have some spin. Let's save it. Okay, so let's spin it a little more. I want a fast spin at the beginning. Always spin and velocity at the braking will hide the fact that they are actually part of particles from our chunks from our object. So let's see, spin, set it to 5, 4. Or maybe use both a full and let's cut, and we'll use a group for spinning group. So let's see, spinning group. I may spell it wrong. So it will be A chunks, and we want I assigned in it. So let's set this dynamic set to spin. Spinning group and paste the spin operator, like so. So let's see. It's spinning but really slow. So let's include. Oops, I set it to 4. Let's see, 0.4. Okay, now it's better. Now we want some friction, for example. Group, spinning group. Or let's rename this not to spinning group, but all chunks. So we want to add some friction. So let's set the friction like so, rotation friction. Okay, it's too big. Oh, like so. Also, we may decrease the attack time to 1. Also, I think it's better to move the spin. Let's see. Good. Or space it back and copy. Copy and let's set it here to see how it will look, because it may affect continuously affecting the particles. Now let's try to decrease the friction. Okay, works much better. Let's set this friction to 5. Okay, now it looks much better. So next, what we want to after some time, we want to bring them back to guide positions. So to do that, we'll create a new dynamic set. We'll name it to bring back, and it will affect only A assigned because they have reference to guides. we'll use some conditions standard time interval. So it's after a frame, let's see, 14, like so. So after this frame, it will use bring to bring the particles back to the reference particles. So let's get the reference. From here, position. So let's see what you have now. So after frame 40, it will start to go back to original position, to the guide's position. Okay, looks much better. We also want to set the same alignment as the guides. Okay. And we also have those chunks that are more than we need. So to get rid of them, we'll use same bring to for them A chunks, and instead of using some guide position, because we don't have any concrete position for them, we'll use center position of the object. You may use anything else, a point or something, depending on the situation. So let's create a helpers standard node. I'll use a sphere node. Let me unhide it. Okay, so we'll use the same bring to particle to position, and also we want to scale by time they travel. So to do this, bring to have an output. They have an evaluated relative, which is outputting a number from 0 to 1, which is the 0 is when it's starting to affect the particles, and on 1 when they are in place, in the position. So we'll use this to scale the particles from original scale to 0. So let's do this by setting a scale operator. Standard scale. So we want to use scale factor with those particles, and we want them from 1 float 1 to divide, to subtract the evaluated frames, evaluated relative, to invert it. Like at the beginning will be 1 and at the end will be 0, because we want full scale at the beginning and 0 scale at the end. So let's set it through scale factor and we'll see what happens. Okay, we need to also fire on the same time interval. So let's do this, and we see that the chunks start to move the correct position. We also want to kill them after that. Okay, so I see one problem. Okay, everything's okay. What do we want to do next? So we have a basic transition. Next, we want to use some more interesting forces. So instead of using just velocity, we may use some wind. So let's create this kind of wind, 0 strength. bigger turbulence, lower scale, standard settings, and we want to influence the, let's rename this to wind, enable it. We want to influence all chunks, so operator, standard, dynamics force, dynamics force, particle, sorry, not force, STD force, like so. We need to attach it to thinking particles, so let's select thinking particles. So select wind through warp, space warp, press H, and select wind. Okay, next we want to deselect and select it again. Now we see wind here activated, and we might start to see some effect. Okay, let's disable velocity for now, and let's increase the turbulence here. Okay, now this looks much better. Maybe a little more. Something like this. Also, we may want to animate the original sphere. Let's say I'll show you how to make sure the animations they are attached to a rigid body animation. So let's say we want, for example, to animate this sphere like rotating around and going somewhere here. Okay. See that the guide stay in place. So we'll actually attach it to create attach guides. There are more methods to attach them, but let's see if I remember correctly what I've used. Follow motion inherit. Let's use motion inherit for now. So groups, guides, helpers, standard node, and we'll use our sphere. Let's see. You can see now they follow our sphere. Except they don't align correctly. So let's fix this. Rotation 100%. Okay. Now let's see. Much better. So you can also animate this torus node. You don't need to do nothing for like you don't need to attach nothing to it. It will just follow its animation, volume breaker. So if you want, let's do this just to make sure. So Alt key. We may also want to change, hide it again, hide selection, and change a little bit the position of our point. like so. So let's see now. One chunk remaining. Let's increase threshold. Okay, now it's much better. So what's next? Next is material. So you need to have some workflow for UVs, so they will have similar UVs, both objects. So what you'll use, you'll use a blend material. So there are different methods that you can use this thing. So you can control the time by simply keyframing the blend material, or you can animate the time with thinning particles. I'll show how to do both. So let's add a blend material. So let's say we have for the torus node blue material, maybe with some noise. Just to see the differences. Okay, some contrast. And so what we want to do is to go to master dynamics and set object group as objects. Okay, so you also can assign material by hand, but I found that group as objects sometimes is easier to control, and also you can add modifiers and other things that you may need. So let's get this group full. So let's set this material. Okay, let's do it for now without group as object, because it's easier with group as object. Actually, not easier, but may get messy if you have many groups, and you may forget to attach the material to some object, and instead we'll just use the original objects. Okay, so into sphere. Let's try to render. Okay, so now we took the material. Next we want to set the second material, like so. I'll use I don't know, something like planet marble. And let's say so first thing you can do is animate them by hand. So you go like this frame, like from here you want to start the transition. So we set this to auto key, set this to 0. Like here you can start to set the second material. So you set the mix to 100%. So you see that in middle you can get the transition. Yeah, to the second material. Or you can use actual thinning particles material time operator. So to do this, we'll go to track view, we'll delete those keyframes, and we'll animate it like so at frame 0. We'll set this to 0, and frame 100 We'll set this to 100. Okay. Now we need to go to our all chunks. If you will have only a group with finger particles set up just for this effect, you can use all group. But if you have more than one setup in one finger particles instance, you can use all chunks or create a separate group. Like, let's say morph particles and move everything here. Okay, so now let's control the animation. So material time. We want when they are spawn, we want to set the material time to 0. Material. So let's set time to 0. Let's copy this operator and go back to this one and set the same thing. Now we want to transition the material here in bring back animation. So set this material and we will expose material time. So we know at time 100 it will be our to have our texture. So we'll use evaluated relative and we'll multiply it by 100. So when transition ends, it will have the new time. And let's set it to these particles. Same thing here. Those particles, evaluated relative multiplier. And we want, I forgot to say, we want to multiply. Okay, so let's see. So we have first material. Should be first one. Okay. First one. Now when they travel to the second one. Let's see. Yes, they have the second material. So the last thing you may want to do is to just to not have this bring operator always in effect. You may want to attach them to move them to another group that will always be attached to groups, but this is at your will. So you can use our objects. Let's see. Let's use a text. So text, happy new year, like so. Extrude it. Okay. Save. Hide this. Assign material. Go to thinking particles. Go to object A and remove the torus and pick the text. You may want to make sure they have the same amount of particles. Okay, also we will need to adjust the animation. So also the raster. Let's see, break one break. We set the raster to 1. Also, don't forget you have spreading possibility in volume breaker, so you can use spreading if you want some more interesting effect instead of using a helper, but it's more uncontrollable. Okay, so you see, we need more particles, so let's set raster to 1.5. Okay, it's too much, I think. Set to 0.7. Too much. You can see we have original particles here, 0.8. So 1, how was 1? Okay, 1 was okay. You can see you have 1 few particles here. So we want to morph into on our text. This one. Want to extrude. Same thing. And we'll use this as target. So create object B, remove, pick. This one, be full, object particles, instant shape, hide. Also we want to use where we've used the node for bring true, so instead of sphere, and then I need to hide it. 1 second. Hide my name, text true. Want to use position of fields, and also attach glide. Okay, now I can hide it. So let's see. Now we have this. Okay, we need more particles. So let's set the raster to something low. Raster to see. Okay, much better. So this is the final. You can cache the animation. Let's select the record file. So press record. Okay, now you can also you can go through master dynamic and set the view to null, so you don't see the particles. So you have something like this. So also you want one more thing to do is to set object as particles. So you have this first group, B chunks, and you want to hide it. Hide selection. Now you have something like this. You can see we don't have too many particles. We'll have to increase this value a little bit to have less particles than the top text. So let's set this to 3. Should be enough. And let's re-render this. Simulate, record. Okay, now let's play. Okay, This is the particles that disappear. I forgot to delete them. Let's see. Node. They scale, and after the evolution relative, we want them to die. So standard particle die on evolution relative. When will it be 1 exactly? Then it will die. So at the end. And I don't like where they go, so I may want to control them to go, like for example in 1 here. So let's use a position. Point. You can use any, for example, a random point on surface. So volume position. Let's, to be more interesting, let's use this. So let's see, node, we have node, and we want to use operator, standard, helpers position, volume position, and we want to use this node, and we want to use this position. Okay, so let's see what we have now. Let's delete this sphere, we don't need it anymore. We want to cache it. Master dynamic, simulate, record. Okay, now they choose random positions. To fix this, you may save a position at birth. So let's do this. Let's do this to finish this tutorial. Something prettier than it's now. So let's volume pose. Let's cut it. And also this, let's paste it back. We need also the node. So we take both of them, cut, go through spawn position, and create object A. No, we want fragmentation. Okay, volume breaking, and we want paste to select random position. One second, I forgot a little bit. Let's see. If we set like so. Particle. We need to set the particle, so we can set the seed, I guess. Let's see, position. Let's see if it will work. Let's disable caching for now. Yeah, okay. So I'm sorry. You need to input the actual particles. You need to input the particles, so it will have the same volume position. See, it will not always choose a new point position. Okay, so it might work right now. Okay, it's working. Also, you may want to start the chunks, the other chunks earlier. So let's set it like so. Out, start at 30. Also, you may want to start them earlier, randomly. So we have start frame, and let's add a random particle and value. So start frame here is 40. We may want to use like 35 to 50, like so. Also, you may use new style of print to see. Let's cache this. Cache. Okay, so now we have. I don't like they disappear. Let's see. A chunks. Yeah. So I might mess something up with scale. Let's see, scale. So okay, sorry. You need to affect scale should affect only when it's in transition. So let's connect this. Should be on. Okay. Also move everything down. So I have something like this. Okay. Now let's see. Cache. Record. Let's see. Okay, now it's working. Now it's too early. You can see them disappearing. Okay, last adjustment, and that's all. So let's see. Time interval. Let's set this to like so, and it should be okay. Record. Okay, so finally. Okay, you got the point. So let's see if we should have a last. So this was the problem that I told you, that when you use group of particles, you may want to reassign the materials. And use manual animation. Or if you what you can do is, for example, hide by name. Let's unhide the chunks group and let's remove group as object. And you can, for example, the B particles, you can, after setting the reference, you can move them out of the screen, so you don't need to hide them. So let's see, position born, position. Okay, so let's see something like so. Okay, so now let's cache this. You also may want to assign materials here. Let's see. So it's now not working so good. Operator material. So they create a TP object type material. Shape material. Particle. And we'll use the material. Instance. Same here. Okay, it will use in the chunks the same material. Should use. Let's see. It may take longer time to cache or a bigger cache file. Okay, let's see now. Okay, now we have the material, but again, it's changing to. So yeah, let's do it to force. Let's do it forced. So let's remove this because I don't see why it's not working. Let's see, good, and let's force it to all particles. So we'll use material. So we'll use group, morph particles, paste, shape material. So let's now try to cache. Hope it will work. Okay, let's see. Okay, it's working. So this was the morphing tutorial, which I shouldn't do it a long time ago, but didn't have time, and my mic broke. So I'm recording now on my webcam, so sorry for bad sound quality. So this is all. If you have any question, leave a comment, and thank you. Goodbye.